All right, welcome back, everyone. So this problem has been requested for a while. We're finally getting to it now. Um, if you're watching this on YouTube, this means I actually managed to solve it. Um, if not, we'll see what happens. Yeah. So this is the last Twitch stream for the calendar year. For those of you that are on YouTube, it doesn't matter. But for those of you that are watching live, thanks for tuning in for the last one. We're finally getting to the Christmas problem, very thematic, and then we'll see how it goes. So this is a problem where you want to partition the set of positive integers into a disjoint union of, for some k, sets which are like a scalar of some times some ki. I'll use capital K for the indexing set. And you wanna... This is only possible for some sets. Like for... Yeah, and the problem is to show that for any set for which this partition is possible, the largest element is a multiple of all the other ones. So n equals 1 doesn't do anything, so I'm going to start by looking at n equals 2, and the question is kind of like, okay, if I have two elements that don't divide each other, like 3, 5, what blows up, I guess, is broadly what's going on. And we don't care about any of the other primes, like, I'm just going to look at the things that are multiples of, like, 3s and 5s. So... we'll put like 1 here, 3 to the 1, 3 squared. So it's kind of a lattice like this, alright? And the question is, why can't I partition this lattice into... Wait. Oh, 3, 5 is stupid because I can't cover 1. Okay, maybe this was not a great example. Crap. So I could do a different example that's like, okay, yeah, n equals 2, never mind. N equals 2, you actually need to have a 1 to cover the 1, so it's kind of like silly. So we'll do like 3, and then I think for the first example I want to draw, I want to do something like, like 1, 3, 5, here. Well, we'll use that as a starting. And then the question is basically, why can't I partition, the set of positive integers into these little L trominos. And the answer is that, well, Okay, so the small cases might not help me very much here, actually, because the small cases are actually too easy. Like, you kind of look at it and you know exactly what to do. What are some other examples of 3-element sets for which I don't have, like, if I want to restrict myself to 2 primes for now, just so I can draw the picture. So for that matter, you also can't partition it into trominos that look like this, even though this satisfies the divisibility condition. You can also consider things like, I don't know. Like if you consider something like, 1, 9, 125 or something like that. I don't know. It's just as an example. This is a set that looks like dun 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 dun. And the question is like, can you partition positive integers like this? The answer also turns out to be no, but I think it's less obvious why the answer is no. But it's kind of like once you start trying to do the tiling, it's kind of like for n equals 3, it's kind of like yeah, so yeah, if you only focus on z to the k, or I shouldn't use k. I'm doubling k. Well, okay, I don't care about the k in the problem statement. Honestly, we're never going to touch the value of k. But it's kind of like I have this lattice, and yeah, I think that's the right way to think about it. You have a lattice, and you want to ask like, can you partition this lattice into certain shapes and their translations? And probably not. Fuck. Oh god. I do not want to. I don't really want to. Can I even do it? Okay, here's a question. Can I even do the two-dimensional case? Because even for the two-dimensional case, like, you know, the question, can I partition it something into something like this? You can have large n for which the problem is still interesting, even with only two different primes. Like, you know. So, I want to just... I almost want to only do the 2 case, just because that way I'll actually be able to draw it, and I'm not... I feel like once you can do 2 dimensions, then 3, 4, etc. might not be. Or here's a different question. Can we even do 1 dimension? Because for 1 dimension, like, technically the problem is vacuous because you'll always have divisibility, but you could still ask the question, like, for which things can I do this shifting thing and cover it? And I think I don't know how much it'll help us if we can classify in 1 dimension all the valid sets, but the fact that it doesn't seem that hard, but it also seems not obvious. So it's kind of like this obvious, like, if I'm not sure what I'm doing and I want more things to prototype against, that seems like a good prototype to play with. In fact, I want to know the answer to that. What is the set of ways that you can tile just the positive integers with translates of a set? Like, which finite sets can you do it for? So if your set has like 2 points, you're fine. If your set is like an arithmetic progression, you're fine. If not, I think if you look at the smallest gap, you might run into trouble. If you're not uniform, you look at the smallest gap between 2 numbers. So I think it has to be like arithmetic progression type things. I think. I might eat those words, but I'm pretty sure. But also you can do it recursively. Okay, the point is that for 1 dimension, you can do it recursively because you don't have any freedom. Actually, you can do it recursively in any dimension. So in 1 dimension, what you do is you say the following. Like, suppose you have your shape, which maybe for us, let's take this as the initial shape. All right. And then you draw your thing. And you're like, okay, here's the starting number. You have to cover it. So you drop, boop, boop, drop, boop, drop. And then you look at the next uncovered number, and then you have to also cover it. And so you must place this thing down. So boop, boop, boop. And then here you get stuck. So in principle, for 1 dimension, you can just do this and see, does the algorithm work? And my feeling is that unless it's an arithmetic progression, it's not going to work, right? Because you just there's no way, right? There's just no way. Let me start that claim. But yeah, the reason this is important to me is because you can also do the same thing in any dimension along any axis. Sorry, that was yeah, like when I put down my domino or tromino or whatever, if I look at any particular axis, like after I had put down this L, I have to put down, to cover this thing, there's only one place I can put it. So in this way, you can get the tiling of the bottom or something like that. Like this axis with the 3s is fixed. Once you tile everything that doesn't have a factor of 5 in it, you move up to the next row, and then you also, again, everything is forced. Like whenever you have a minimal by inclusion, or just any minimal by anything element, you have to put a domino there. Yeah, so for any set, we basically have an algorithm that will tell us either like it's gonna work or not. And then the question is, okay, like, sure. So then I wonder, like, what does the max thing say? The max thing says that, arrows. I do like I do kind of like this arrow idea where you're like, if you have a shape and like if I have a Tromino shape and the bounding box like this thing isn't present, I could draw an arrow here. So this will give you this chain. This guy, in order to be covered by anything, well, this one has to have like another L thing on it because it's not covered and, well, no, that's not quite true. Never mind. It should have another. If you start from the bottom, it will, I think, or something like that. Like there shouldn't. Is that true? I have to think a little bit about that. Wait, I actually don't see examples that aren't just like rectangles or like products of two. So here's a question. Even in 2 dimensions, is there an example that isn't just like arithmetic progression, Cartesian product, arithmetic progression? I feel like there isn't, but I'm not 100%. Young tableau is not the right buzzword here, I think. Like, young tableau is too general. Oh, actually, no. Young tableau is just wrong. Because, like... Sorry, yeah, it's not even too general. It's just wrong. Because, like, this one... So this 4-element set you can tile squares with. And that's not young tableau because there's like a gap here and a gap here. But I think like every example is like arithmetic progress. I think for at least 2 dimensions that I can tell, every example I've seen so far is like arithmetic progression, Cartesian product, like arithmetic progression. What does it mean it becomes a young tableau? Like if you take mod, it tessellates a young tableau. Oh, I see. Yeah, maybe. Okay, fine. Fine. Okay, but anyways, someone wanted to help me do the one that, like, even in the one-dimensional case, how do you check that it's an arithmetic progression? Like, I have this algorithm. I'm very confident that it has to be an arithmetic progression. And okay, it's like you look at the gap at the start, and then however much of a gap at the start you have is, it's just so annoying. Like I can't write down. I'm sure it's true, but I cannot write down the actual proof. Where if I have a one-dimensional thing, you put the next few copies in. No, yeah, it's just. Okay, I have to do the 1D case. I think I'm not gonna get anywhere if I can't even do the 1D case. So suppose I had like something that's like gap 1 and then like I don't know, something out here, and then I fill this in, shoo, and then shit, I need to pick a number of holes. Let's do like 2, and then you die. Right away. So maybe I need more. Maybe I need like a lot of holes. Maybe that's what I need in my life. More holes. Bom, 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 bom. Yeah, this other thing, there's a thing I've been wanting to try as well, which is just like if I have it is a generating function, right? Like, in principle, it's like this times the sum of like some things has to be equal to 1 over 1 minus x. And then it's like, if I write it this way, is there something I can do to... Like, do I believe this? And I think the answer is not. Super. So, like, there's this thing where it's like, if I had like 1 plus x squared plus x to the 4th, which is an arithmetic progression, this is going to be like 1 plus x to the... It's going to be every 6, right? Which is like 1 plus x times 1 minus x to the 6 or something like of the shape. Like, this is true. This is true. I don't really know what to make of that. But it's like, are there any non-obvious generating function identities of this shape? And my hunch is definitely no. If you could do something weird with this, someone would have told me by now. But I don't know how to, again, I still don't know how to prove it. It's... So here's an interesting question, actually. If I take this identity here, is there a root I can plug in that will blow everything up? There is. So if this polynomial is not exactly a cyclotomic polynomial, then it's a complex polynomial which has roots that are not... I can plug in a root which is on the unit circle. Sorry, which is inside the unit circle. So any root of absolute value less than 1, that also causes this yellow thing to not be 0, I think. And when I plug that thing in, this thing will converge to something. And this thing will equal 0. Left hand side is non-zero. Pray to the gods of generating functions. This is something that I've never figured out. I am so scared to plug in numbers into generating functions because I never got the formality right. But I think this should be okay here. Which is you plug in one of those roots and it's bad. So in the one-dimensional case, it doesn't matter, plug in pray. Yeah! We vibing! Yeah, you should play something with absolute value less than 1, and then everything should converge. There's TLDR. So, in the one-dimensional case, what this is telling me is that my thing should have every root of it has to be on the unit circle. I think. But also the coefficients are either 0 or 1. Is that good enough to do anything? I can't tell. Is it true that a polynomial with coefficients that are either 0 or 1, and with all the roots on the unit circle, needs to be just an arithmetic progression? Is that a true fact? I have no idea. You doubt it, really? Okay. Because I actually believe it. I know that there's polynomials which are not related to cyclotomic polynomials, but for which every root is an algebraic integer that happens to lie on the unit circle. No, sorry, that's false. Oh, hang on. Oh, no. Wait a minute. You know, you guys are baiting me, right? This didn't I put this on int poly? This is a true fact, right? If any integer coefficient polynomial has only roots on the unit circle, then those roots are all roots of unity. Those roots are all roots of unity. And here, because your constant coefficient is 1, all of the roots, like, the roots have product 1. So either they're all on the unit circle and it's cyclotomic, or one of them is inside the unit circle and you bust the whole thing immediately by plugging that one in. So, good. We know that the polynomial has to exactly be a cyclotomic polynomial. Moreover, the coefficients are 0. So what I'm trying to rule out now is, like, you know, are there cyclotomic polynomials? If the cyclotomic polynomial, all the coefficients are either 0 or 1, is an arithmetic progression. It has to be, right? Most cyclotomic polynomials have -1s in them. I firmly believe that. Alright, so it could also be a product, but... Okay, wait. If the coefficients are all 0 or 1, what else can I say? So I know it is a product of some cyclotomic polynomials. But also, if it's the product of some cyclotomic polynomials, then it's also true that all the roots are exactly nth roots of unity. So in principle, do you get like some sort of periodicity of some sort? Like, it seems like it should suggest that at least it's like you have some really good periodic structure. Cyclotomics of non-prime power n have negative coefficients. Ah, there you go. Right, because their value at 1. No, hang on. Wait, yeah, what do the cyclotomic polynomials evaluate to at when you plug in 1? I actually don't know off my head. I see. Okay. Okay, but I guess the broad strategy is that we think that... I see, okay, but it's like products of multiple cyclotomic polynomials. Okay. But in that case... I feel like I should know the fact. Uh, okay, I needed to. Hmm. No, no, that's not true. Let's try. Yeah, tablet does that work. Yeah, I like the polynomial thing. I think the like generating functions are just unusually. I have I have been consistently surprised at how well generating functions can handle translations. Like even when it seems like they shouldn't have enough power. I wasn't expecting the cyclotomic thing to do anything, but we've already managed to show that any polygon has to be a product of cyclotomic polynomials just by plugging in a certain complex number if it's not. Which I don't know. Like all these years later, it still surprises me like how strong the idea that you can capture translation using polynomials is. Anyways, for the present thing, I still want to force it to be an AP. I know it's a product of cyclotomic polynomials, and I want to wait. Oh, hang on. That's a true fact. So it's possible we don't need to finish this part. Because in the general situation, what we have is the general situation is that you have a product, like you have a multivariable polynomial, for which Shiba.
She's got a lot of talent there.
Oh, I thought you'd think so. I was a model back in Texas.
Let me just write the two variable case for concreteness. Like again, it's like you have AI, Y, BI, some finite thing that looks like this. These are your things, and then also like some X, some infinite set like this. And as long as you can show that this polynomial factors in X and Y, you're gold. But in fact, so just by plugging in y equals 0, i.e. like projecting to one axis, you already know you kind of have a good control of the bottom. And in fact, it's sort of like saying for every value of y, all the roots of the x to the ai are cyclotomic for like varying y. And I honestly don't see that happening. Like if I plug in literally any value of y with absolute value less than 1, then your whatever this thing is supposed to be a polynomial which is a product of cyclotomic polynomials. And I think there is there's good discreteness reasons to believe that won't. Wait, how can that possibly be true? Is like multiples of a cyclotomic polynomial. Sorry. Uh. Uh. Yeah, hang on. Yeah, so something's sus here. This shouldn't happen unless like it really factors, right? Uh, 1, 2, 16, 32 is an 8. Oh, wait, are you saying you can tile with 1, 2, 16, 32? Shit. Fuck, you might be right. Hang on, let me verify that. I think you're right. Well, actually, if you're telling me this, you're definitely right because I think you've thought about the problem before. You never run into convergence silliness? No, I don't think so. As long as your absolute values are less than 1, we don't. Nothing bad happens. Like, it's like fix a value of y. Fix any value of y with absolute value less than 1 and then focus on just the x part. No, you don't have to plug in a root for y. Wait. What's the issue? No, I don't see what... Well, I haven't done anything yet, so I don't know if there's anything to be wrong about, but I feel like this must... Like for example, when I plug in y equals 0, equivalently project onto the bottom axis. It tells me that my bottom, the y to the 0, okay, here. This thing is some finite combination that's like y0 times some polynomial in x, y1 times some polynomial in x, and something here, I don't know. Arithmetic progression, which it sounds like people are telling me that me thinking that it's only APs is false, which I'm a little surprised by, but also I don't care because it doesn't affect the thing that I'm trying to prove. Like, I'm trying to prove the polynomial factors is what's going to happen. And I thought in the 1D case that, in fact, every polynomial should have its exponents in arithmetic progression, but if that's not the case, I don't even... It's not a big deal. Like, it's not relevant to what we're trying to prove. Yeah, so for example, when I plug in y equals 0 into here, like, this should just... y equals 0. This stuff all goes away. You get a one variable thing. Like, it's just projection onto the bottom. But similarly, if I plug in any particular complex number with absolute value less than 1, I mean, this is still just a polynomial on x. The coefficients are screwed up now. They're not necessarily 0 or 1. But it is still oh, hang on. Okay, I do need to make sure the constant coefficient is 1 for the argument to go through. Shit. Yeah, but the thing about y is that when I'm picking this value of y, I have a ton of choices. I have so many choices. You have a whole continuum of choices, and you're being told that for all of them, the roots of the PI, like basically the end goal is that I want all the P's to be the same. But what I have is that when I vary Y, I'm being told that all the roots are always lie outside the on or outside the unit circle. Because as soon as I can find a single pair x comma y, which is both inside the unit circle, I can plug them in, and if it's a root of the bracketed term on the left, everything blows up. Box is a bit of a misnomer. It's more like open disk something something. But it's there's no way, right? Like, so plugging in y equals 0 tells you that this is a polynomial, all of whose roots are on the unit circle. But I think basically for complex analysis reasons, like imagine plugging in like y equals epsilon or something. Like if the PIs are different, I can't imagine this ever working, like just at all. It's a little In fact, here's an idea. What if I let y be like something on the unit circle times x? The reason this is useful to me is because that way the constant coefficient of this polynomial, so y becomes a multiple of x. The constant coefficient of this polynomial is still 1. Yeah, it's still 1. Because now so the product of the roots is all 1, but we're also told again, so they're all in the unit, they're all in the unit circle. I almost want to try to like do some sort of continuity shit, like. Or, in fact, I can, so y equals r times x or something? I don't know, man. Who knows? Fuck, I feel like this must work. Oh god, you want me to quote Putnam problems? No, I feel like this must work. Like I think there's no way the polynomial doesn't factor. So I need to stake this claim. If I plug in a root for I can't quite plug in a root of P0, but I want to do something like it, and then like I don't know. Like the condition is way too strong. Like the fact that all the roots have to lie on the unit circle. Oh, actually, sorry, I lied a little bit here. This is a little weird now. Because if I let y equals omega times x, then what's the leading coefficient? It's something that's kind of weird. But you actually know that the leading coefficient is supposed to be So in the case where the problem is true, the leading coefficient is some power of omega. Otherwise, it's not. It's equal to something like... I feel like I keep doing these random substitutions with... I can force the coefficients to not talk to each other, right? If I just put like some big number here. Again, all I need is the PIs to be equal, and then I can factor, and like everything's amazing. If I can factor, it implies the problem statement. So if I put y equals like x to some large power, none of these things talk to each other. You're told that for every y, yeah, there's just no way this is gonna. It's like I have these polynomials that aren't interacting. I know the leading coefficient is something, whatever it is. Who knows? I don't care. Fuck, I have like 20 minutes. I feel like I must be able to do this. Yeah, the problem is there's so many parameters that... You can imagine like, you have the roots of the polynomial, and as I vary omega or something, the set of the roots has to be continuous, right, in some way. Like, you know, you have the root set of roots when you plug in a particular value of y. Like, say y equals 0. You have a finite set on this unit circle. And then when I vary, if I perturb it a little bit, like, the set of roots should move to something else. Like, in some continuous way. Fuck, I'm convinced this will work, but I don't know the machinery. Like, I almost feel like I'm trying to do algebraic topology. But you can imagine, like, when y equals 0, right, you're told that all the roots of this polynomial are these things on the unit circle somewhere. And then, so this is the y equals 0 picture, and then, like, when y equals, like, a half or something, they've, like, moved to somewhere, you know, some other set of 5 points. Or, no, it doesn't matter if it's 5 or not, it's, like, some set of points. And my claim is that the set of roots for a particular value of y, like, when I go from 0 to 1/2, they should move continuously, but also they're all supposed to be cyclotomic, which is like a disconnected set. I don't think it has to be on the unit circle anymore. Shiba. Why not? Do I fuck everything up? So what I need for that to happen is I need to, sorry. Let's do 1/2 x. That way the constant coefficient is still 1. And the leading coefficient, oh shit, it's, it might not be, oh god damn it. Yeah, but the problem is the leading coefficient isn't necessarily 1, so the Vieta argument no longer applies. Yeah. Yeah, but the problem is the leading, when you do y equals omega x to, actually, hang on, do I need omega to be small for this to make sense? Like, ostensibly, if I fix... But the problem is, like, if y has large absolute value, my convergence of this thing might mess up. Like, it... No, but see, the result is stronger than the roots are on the unit circle. The roots are specifically cyclotomic things. Like, the roots lie in a totally disconnected set. Like, the set of possible roots for each value of y that I plug in. Like, it's not, actually, I don't know if I even care about the unit zero. It's just like it's not even a connected set. Like if I you can't it's like I plug in y equals 0 and like y equals like 0.1, like somehow the set of roots moved in the complex plane, but no, it's oh fuck. No! No! No, I think the polynomial factors you win because then like the maximal term is there. Like the problem only asks us to show that the term of highest degree is a multiple of every other term, so as long as the polynomial factors, you're okay. It's like basically what I want is the set of roots of a polynomial to not change when I like poke y a little bit, but I can't quite force it to work. Like y equals 0 is the good case, and then I need to change y in any way that doesn't screw everything up. Like I really want to plug in y to be like some but there's just no way. Like I can I really want I know that the constant coefficient will be 1 kind of as long as y is really tied to x. I really want the leading coefficient to also be 1. However, what if I just use x to the large? If I just use x to the large, like full stop, does that force the leading coefficient? Yeah, I think that forces the leading coefficient to be. Yeah, if I just plug in y to the x equals to the big, the leading coefficient is 1. Maybe that's all I need. I've been trying to do continuity shit, but maybe I don't need the things. It's just now I have this discrete set of polynomials, and I'm told that all the roots are always on the unit circle for any value of any sufficiently large value of x, or of the exponent here. When I plug in x to the big, if big is large enough that the leading coefficient of everything is 1, then again all the roots are on the unit circle. And I want to say this shouldn't really be. It's like so what I'm gunning at is like x to the 0, x to the n. I shouldn't use n. Let's use a capital N and like x to the d n or something. I'm told that for every sufficiently large value of n, this sum has roots only on the unit circle. Because the leading coefficient will be whatever comes out of this thing if you take n larger than the max of the degrees of the PIs. And yeah, so the claim is that in order for this factorization to be possible, I would want all the roots to always be cyclotomic, which I want this to force the PIs to be equal, given that they're supported in 0, 1 coefficients. And sorry, I might be smoking a bit. It's not true that the PAs are all equal, right? Like, it could be that I want them to either all be equal or 0. I want each individual PI to be like either 0 or P0. It's not true they're all equal. I mean, because you have like 1 plus x squared times 1 plus y squared, for example. But I would like to not have two different non-zero pi. Can I force that to be the case? Can I bound the size of the cyclotomic? I guess, but the thing is, like, as n grows large, frick. There is kind of a bound, but it's not a good one. I just feel like this feels so implausible to me, but... Okay, maybe I should bring in the scale. So the other thing, I could scale, like, you know, x to the n. I could put, like, a zeta in front of it. That way we still have the continuous parameter while we still have control over the leading coefficient. Maybe that's the idea. So I put some epsilon such that absolute value of epsilon is 1. And now I have, like, epsilon, shit, right, wrong pen. Epsilon, and then like an epsilon to the d here. And then, yeah, the claim is, okay, now I think the continuity. So for each epsilon equals 1, so this has, okay, the constant coefficient of this blob, let me write this down. Constant coefficient is 1, and the leading coefficient is epsilon to the d times, yeah, it's just epsilon to the d, which also has absolute value 1. But I can vary epsilon around the unit circle, and this is some polynomial, which, yeah, basically the roots aren't going to change. This was going to happen. Wait, something's wrong here. Sorry, they're not cyclotomic if okay, sorry. The discrete thing is never going to work. The reason it's never going to work as written here is the Kronecker thing only works if the coefficients of everything in play are integers, which is not true. So I can't just do discrete things. Nevertheless, even then, just when I imagine moving epsilon around the unit circle, I feel like I can't imagine the set of roots staying on the unit circle unless the polynomial is like very special and factors nicely in some way. Yeah, so maybe I don't need to do the number theory part, and I can just try to do the analysis part, where I have this parameter and these polynomials with completely disjoint polynomials in the sense that yeah, and then I'm told that no matter how I vary epsilon, the roots are moving on the unit circle. And that seems like super, super strong. But I don't know the complex analysis required to pull this off. Shiba. Yeah, when epsilon equals 0 or when epsilon equals 1, I know that the roots are on the unit circle. Or I know the roots of P0 on the unit circle. Ah, damn. Okay, you have a claim, which is that if I plug in a root that's close enough to 1, something breaks. I'm not sure. Yeah, it's like I can either vary n, in which case I know the roots are cyclotomic specifically, or I can vary like I have this twist by epsilon. Still, the roots are on units. Yeah, I'm convinced that this is the correct route, but I don't know how to. I don't know complex analysis well enough to execute this, and I feel like this speaks to me like complex. Like it's saying my roots are super constrained, even though I have a ton of parameters, and it's supposed to force the p's to all be the same, or at least have the same set of roots. But I can't force it. I don't see how to force it. Anyone knows like how to do Rouchet theorem crap? That's like one of the things I never learned. But it seems like it might. This feels like the kind of situation where you want to pull out something like that. Maybe, I don't know. Rouchet, yeah, that's one of the techniques I never actually learned. So, but I would. But yeah, even with epsilon equals just 1 period, like it feels like there's no way this is. Okay, I'm gonna look inside. I wonder if I actually need. See, the bound on the Chronicle thing is so bad because it's like. What you do is you consider like. It's like there's this n of choose n halves to the n+1 type garbage. I almost want capital N to be like a large prime or something. I feel like if you take capital N to be a large prime, you can try to force a factor. Can we? It's not going to be irreducible though, right? Is the problem. No, I feel like it has. This has to be. When I plug in a root, like when I plug in a large capital N, let's say capital N, I have some integer division with some cyclotomic root of what am I not seeing? Yeah, I don't know. I feel like that's a little. I feel like if I need to use that, I'm screwed anyway. Like, damn. Mm, hmm. Yeah, I just don't know integer polynomials well enough. That's the problem. If you really knew your theory of integer polynomials, I think you should be able to see what to do here, because it's just so obviously implausible that the roots will all happen to stay on the unit circle no matter how you pick n. But I don't know how to show it. So if there's a let's say there's a root. Okay, so I picked some big N. Suppose there's a root zeta, which is an primitive mth root. That means I should be able to take this whole thing modulo x to the m minus 1. And it needs to be divisible by like phi of m. However, dn, are there even enough terms or something? Like, I feel like, so I do this reduction, and phi of m, so there's like some finite degree that I can have, n plus 1, it's like n plus 2, up to... So when I reduce everything mod m, these are like some exponents which will be like not too huge, like something less than or equal to m. The secatomic polynomial in M has degree at least root m. No, that's not. It's like n is. Yeah, I don't. I think I'm fighting two different growth rates. Like. Because m can depend on n, that's the problem. I think this can be used to show that if I pick a large... I'm not sure where I'm going with this. I think I can feel that I'm quite close to the solution, but I don't think I'm not sure I'm actually going to be able to finish it. I want to plug in a root of unity and force like, cause I have control over capital N. In addition to making it large, I could also do stuff like make it a prime number, and try to if I make capital N to be like a large prime, I can try to force it such that any root of unity has to be... Because if you plug in something that's off... Well, I'm not sure. No, wait, hang on a minute. Wait, there's a lot of roots, right? Like, this polynomial has, like, many complex roots for large n. Hang on, wait, every root... It's not just like there is a root. There's a... like, virtually every root. Does that do anything? Okay, that's strange. If virtually every root... Like, actually, well, not virtually. Like, literally every root is a root of unity. that might be a lot of roots. And so there's like a polynomial of degree little d times capital N plus degree of PD. And it needs to split as the product of like lots of cyclotomics. Okay, I should write down some examples. Like it's sort of a thing where like you can imagine you have like I don't know, man. It's like 1 plus x squared or something, and then like 1 plus x, and then I'm telling you that like I multiplied this by like x to the 1000, and then I multiplied this by x to the 2000, or some other equally ridiculously large number, and then like everything is a root of unity of like some degree. And I don't think something feels wrong, but I can't say exactly. It's like I need to I really needed to factor, but I can't see how. Maybe I shouldn't use 1000. Should I use like a prime or something? So just for complex analysis reasons, like when I plug in a root of unity, that is okay. So if there's a root of unity, then by if there are roots to this, then if there's like a primitive nth root of unity, we can take the one that is closest to 1, and then these things, if the no shit, this is too complicated. I really wanted to say like these things are close or something to like x is close to 1 and then something, but I don't think that's gonna fly. If I put in like thousandth roots of unity, like if I put in a 1000th root of unity, I guess yeah, maybe, I'm not sure. But this is a polynomial degree like 2003, so there's like a lot of roots. But I just can't force it. I don't see what I'm missing. I'm convinced that the solution is along these lines, that you're taking some polynomial and like arguing that there's no way the roots behave like this. But I don't see how to finish. Like, why is it that this can't plausibly always have cyclotomic roots? Or I can bring back the epsilon. Shiba, 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 yeah, okay. Okay. I guess I should do the discontinuous version, huh? From the fourth direction? I don't know that. Okay, so you're telling me that I'm not supposed to do the integer version, I should be doing the continuous version. Okay, fine. We'll do the continuous version, in which case we're definitely bringing this epsilon back. So, I'm sorry, I'm a number theory PhD student, alright? I wanted to not do complex analysis. Okay, so we bring back epsilon, and now we have an epsilon factor to play with. So in exchange for losing all access to number theory, the claim is that for any epsilon such that epsilon equals 1, this thing was supposed to have only roots on the unit circle. And I want it to factor. In fact, if I pick n large enough, I can cause these to be 1 if I wanted to, which is fine. I'll post the... I didn't mean to... Oh. I mean, if you're going to do the... You're saying that I can have epsilon equals 1 and still have analysis issues. I guess that's fair. Oh, I'm so sorry. I finally realized what you were saying about the reciprocal thing, which is that when So in the integer version, it is actually a reciprocal. Oh, okay. I see what the reciprocal thing is saying now. Which is in the integer version, if you had a root, then its complex conjugate is also a root, and ergo the polynomial should read the same forwards and backwards or something like that, because 1 over x is also... Oh, hang on. Okay. I don't know. Okay, I'm being told I shouldn't be using the epsilons, but do I just have analysis issues? It's like for every n, all the roots lie on the unit circle. And then I don't see where I'm supposed to go. Also, my board just stopped working, so that's a big L. Miro is being updated. Okay, we're back. Okay, so I'm being told do this, but don't do the don't try number theory. Just use analysis. In which case, the fuck do I do? Yeah, no, I can tell that I'm almost there, and it's driving me nuts. I'm like, oh god, I just need, like, I need. There's one more. I think there's like one more idea I need, but I don't see what it is. Twitch chat, help me out. It's like I plug in What do I do with roots on the unit circle? Wait, I actually think the number theory is supposed. So here's the thing: like, if you have a primitive nth root, then all these expressions here are like close to integers. So the only way for like if I plug in a large n and there's a primitive root, there's like a cyclotomic root of like close to 1. These are things that are practically integers. So in order for it to plausibly vanish, even for analysis reasons, like these integers need to be pretty close or something like that. I'm not. I don't know. No. Fucking. Shiba. What? It's just so weird. It's like I have I know the complex numbers in play are on the unit circle, but it's like when it's like when x is close to 1, for example, like relative to 1,000. Like these things are practically just like 3, 2, 2, and then these are the main things that are contributing. We're not supposed to consider the units. Wait, what? Wait, what are you supposed to... Wait. No, the whole point of the power of the argument was that you could say that I can plug in... Okay, are you saying that I can just plug in x and y directly? Like find a pair... If it doesn't factor, the claim is I should be able to find x and y such that x has absolute value less than 1, y has absolute value less than 1, and this thing is 0. No, I think we're being told the number theory is bad. I don't think we're being told that the like unit circle is bad. I don't know. I mean, I don't know the solution, but yeah. See, I told you you're supposed to use the unit circle thing. I'm like looking at this and it's just like I mean, the point is that like you have like 10 million parameters, and you're being told the polynomial always has only roots on the unit circle, which is like in every like, you know, like especially with the epsilon. Like with the epsilon, there's just absolutely no chance that the like a random polynomial will somehow all the roots will magically stay on the unit circle as you vary both epsilon and capital N. Um, but frick. Oh man, yeah, this is sad. I think like the first like half hour of this solve was like maybe not half, but like the first 45 minutes of it was like useful content, and the last 45 minutes have just been me like trying to push this last thing through and not knowing how to do it. Like I just fuck. Yeah, like I know that this is what, like it has to be this. Like it feels so right, but I can't get the last. I can't get the last move. I don't. I wonder if I should be staring at the Vieta a little more, because there is a thing which is like the a lot of the symmetric coefficients don't change. Like there's a lot of roots. Actually, no, the problem is there's so many roots. Like every root is supposed to have absolute value 1. And if I have 2003 roots with absolute value 1, and there several of the first however many symmetric polynomials aren't changing in the whole time. Like for example, like I have these 2003 complex numbers in this example, and the sum of the reciprocals is still -1, and the sum of the squares of the reciprocals is still -2, and so on. Or sorry, sum of the squares is whatever it is. But they all have absolute value 1, and like must have a maximal term. Yeah, but like I think the point is that it has to just factor, right? Is the claim. So okay, how do multivariable polynomials work? Does anyone have any idea? Because I don't. Like we're in the square. Yeah, but the problem is we don't. I had the same combo null thought as well at some point, but the problem is like I don't. The set of roots keeps changing, so it's just kind of like I don't know. But I feel like we should be doing the continuous version anyways, because we keep dying. Every time we keep trying to do the number theory thing, it doesn't really get us anywhere. Especially since we think that like the 1, 2, 16, 32 example or whatever from earlier, like it's not. It's not great. We're gonna look up Ricci's theorem. Um. Oh wow, this looks really relevant. So, wow, the number of roots inside a circle, or any closed region K, apparently. Okay, so it's like if you have a small offset, so I don't know if I have a small offset. Actually, I'm not sure it applies here because the things are about the same size, so it's not great. A dog on a leash, yeah. But see, if I had the epsilons, then I could. Yeah, but the problem is if epsilon has absolute value less than 1, then the unit circle no longer helps you because you're not. Then you don't get convergence of this thing when you plug in the small things. Wait a minute. Sorry. No, if epsilon is less than 1, the problem is that Vietta's for. Yeah, Vietta's formulas don't work anymore. The roots can be. You need the low leading coefficient to have absolute value 1 for this to go through. Okay. Well. Man. Yeah, I mean, okay, so you're like. Yeah, I don't see it. Okay, I think. God damn, what am I missing? Shiba. Yeah, I don't like. What does it tell you if all the complex roots have absolute value bigger than at least 1? I just don't think so. Yeah, no, the variable, yeah, but wait, I don't see where you're getting at. Like, we know this, that part we've figured out, right? So we know that in this reduced polynomial, the constant coefficient is 1, still, leading coefficient is still 1. All the roots are on the unit circle. So, I mean, yeah. We've been there for like an hour now. uh, am I missing something stupid? All the roots are on the unit circle. No, yeah, like... What? The fuck? Wait, I don't... What? What if x equals 0? I don't get it. What? Huh? What? What am I not seeing? Every root should also have its reciprocal, as a root says a lot. I think the reason I didn't push this is because it only tells you that, like, this and... Wait. Also, the reciprocal thing actually requires the integer thing. Okay, but I mean, okay, so you're saying that, like... Yeah, you're saying that these two things should be the same, which is fine. Like, that's part of the palindrome thingy majiggy that I... But I don't... Like, what does it do for... Does it do anything in between? The fuck? I should read this in forwards and backwards. Motherfuck. No, but the palindrome only helps you with P0 and P... Wait, okay, what? Okay, now you... Now... What the hell? Alright, so... The top and the bottom are but... It only lets you pair things up, right? Oh, maybe that's... Is that good? Okay, well... Yeah, we brought up the palindrome thing like a couple of times, but I don't... Do I want it to be palindrome? Oh. I see. You do the same thing in Y. So you switch the roles of X and Y. God damn it. I see. So you... Yeah, but it is because you fix each variable. Oh, come on. Are you shitting me? Oh, that's just rude. Alright. I wasn't gonna get that. I'm thinking... I see, okay. So... For fixed y, yeah, for y equals x to the n, it's a palindrome. When you put y equals x to the n, you get a palindrome thing, and then when you put x equals y to the n, you get another palindrome thing. And if you don't have the divisibility, I don't think this is compatible. Well, for that matter, like P0 is itself. Yeah, it's. Oh, you're not getting the intermediate ones at all. You're just ignoring the center. Yeah. It's. How do I say it? Like the palindrome argument is that if you look at like the here's like the bottom x and y to 0, x to the what 0, and then x to the whatever, and it's like this is a palindrome, and then we know that the top thing is some other is the same thing. Like the top row and the top two rows are the same, is what's happening. And then similarly, like, the top... Also... Oh, the bottom row is itself a palindrome, and the top row is a copy of it. Similarly, the leftmost column is a palindrome, and the rightmost column is a copy of it. Fuck, you just ignored the center. You actually just ignored the center. Oh my god. That's so rude. Here I was trying to like classify the polynomials. Wait, okay. Is it true that it has to factor? Do we know if it's true it has to factor? I know we don't need it because this solves the problem, but also, what the hell? Oh my god. I hate this. I'm not sure. Oh my god. We don't care about anything in the center. The bottom row is a palindrome, the top row is a copy. Left column is a palindrome, right column is a copy. And that's it. Oh my god. Well, yeah, the palindrome thing says central. Oh my lord. Oh, it's you were trying to prove. Oh. No, I don't believe you when you say if there are weird constructions that don't factor out. 1 plus xy. Ah shit, you're right. Okay, never mind. Oh, wait. Wait, oh, you guys are... Okay, why did no one... Oh, this is why nothing was working. Oh my fucking god. You guys, like, hello? Like, this is a tiling. Oh my god, that's why nothing was working, because we thought all the examples had to factor, and there's literally 1 plus xy where... Oh my... That's why. We weren't supposed to try to show it factored. We just wanted centrally symmetric, and we had the palindrome idea. But we were convinced the stronger claim was true, and thus got wrecked. Okay. Well, alright. No, why did you tell me about 1 plus xy? We could have been done like an hour earlier if you had mentioned this fucking counter example. Holy fuck. Oh, okay. We'll play it. Incidentally, when I set the top row as a copy, like, okay, oh my god, it doesn't factor. I'm so stupid. I'm so upset right now. Why did we... How did I convince myself it had to... I convinced myself it had to factor. Oh, no. Oh, terrible damage. Okay, well played. I'm not writing this up. Oh god. Someone else write this up. Yeah, great problem. I hate you. I'm... Wow, that was terrible damage. Oh my god. Like, if we had known that this thing existed, I think we would have been done a long time ago. Because we kept trying to prove something that was... I was just like, this has to be true. There's no way it's not true. Oh my god. Literally, like, 2-term counter example. Oh my fucking god. Alright, well played. Alright, I don't...